person for today's session, Miss Nikita Gugale. Miss Nikita is a senior blockchain engineer and a subject matter expert at IDS with over 5 years of experience in designing and deploying mission critical decentralized applications across leading blockchain ecosystems. She has extensive expertise in smart contracts, chain code, Web3 applications, and decentralized solutions across Hyperledger Fabric, Hedera, Polygon, Polkadot, Algro, and other blockchain platforms. She specializes in blockchain technologies, including DeFi, NFT marketplaces, tokenization, decentralized identity, decentralized autonomous organization, and supply chain solutions. She has successfully led high impact blockchain projects and managed across functional teams in delivering secure, scalable, and production ready digital platforms. Ms. Nikita is a Hyperledger Fabric certified practitioner from the Linux Foundation and alumnus of prestigious Polkadot Blockchain Academy, Singapore. Behind her technical accomplishments, she is a passionate educator who has trained more than 5,000 professional faculty members and students through AICTE faculty development programs and corporate training initiatives. Her exceptional technical expertise, industry experience, and commitment to the knowledge sharing make an outstanding speaker for today's session. On the behalf of Department of CSC and CSC AML, the Gopalan College of Engineering and Management, Bengaluru, it is my privilege to extend a warm welcome to Ms. Nikita.
Thank you, ma'am.
Good.
Thank you so
Uh,
much.
Ma'am, over to you.
Yeah. I
Thank you.
hope I'm audible and my screen is visible now.
Yes, ma'am.
Yeah.
Your voice is audible and screen is also visible. Good to
Yeah.
go, ma'am. Thank
Yes.
you.
Thank you for the confirmation. Thank you once again for having me and greeting me with such a warm welcome. Before let's start with the session without any delay anymore. I welcome you all for the Blockchain Security Essentials, where in today's session we are going to cover two major parts which are majorly included why blockchain security is important, and these mainly rely on two pillars. One is the infra of blockchain and how it works, which comes under the consensus mechanism, and the next your operational part, your development part, that is your smart contract security. So the roadmap for today's session is: first, we'll understand what is consensus mechanism, how it is used in your decentralized trust, how it is needed to make your decentralized systems. One of the major how this consensus mechanism rely one of the mechanism, that is Benzenide's general problem, and how we have a solution for that. Apart from that, we would be looking at different consensus mechanism and what it brings to the table in the way that it is secured, which is majorly proof of work and proof of stake. One of the most leading blockchain, one of the most leading platform, that is Hedera Hashgraph, will look into it, where they are using the utmost security using the benzenite fault tolerance. That would be on the consensus security part. And the next very much important part would be on the smart contract security. What are the fundamentals of smart contract? What are the vulnerabilities that are already being there, how they are managed by the developers, what are the practices that needs to be taken so that these are secured contracts. And also looking into the real world use cases, and what were the securities been given out, and the use cases that is being used, and how we are going to use this the secured way with whatever the experiences or whatever the use cases we have come across. We had some learnings from that, and how we can implement so that henceforth we have a better secured applications and secured system running. We would be also looking at few of the cases that is already been there, and what were the learnings from that, and what are the different practices that we are going to look into. And we would, by the end of this, the conclusion would be you would be knowing with more of the secured systems of the blockchain and its practices that needs to be looking into priority whenever you have your application running. And after that we would start with our Q&A session. Okay. In today's case, blockchain is not only with respect to the cryptocurrencies that are there. It is way beyond cryptocurrencies. Cryptocurrencies is just, we could say, a tip of the mountain in the blockchain space. Apart from that, we have multiple applications running on digital assets, on financial transactions, on your bridges, on your identities, multiple applications for your education purpose, for your medical health, where you have your data on this decentralized ledger technology running. And at most, if there is a technology, if it is going to be digitalized, there is going to be threat, because that is inevitable. And therefore the security of the blockchain also matters at the most. Okay, before we start, I have two questions for you all. uh, are you familiar with the blockchain, the basics of blockchain? What is blockchain? And if you are familiar with this, why do you think that the security is important for the blockchain? You can put your answers in the chat if you're not comfortable to unmute yourself. Anyone? To my first question, can I at least get a thumbs up if you know what is blockchain?
The participants can unmute the mic and they can answer. Mic is
Because
allowed.
I am assuming that you already know what is blockchain, and if I conclude with that assumption, and if you don't know what is blockchain, then you won't understand the complete session. So I really request everyone to let me understand like where you stand with your blockchain concept.
Good morning, ma'am. As per I
Yeah,
have
hi,
the
hi
idea
Nikita. Good
regarding
morning.
the Alekhya, sir.
Yeah, hi. No, actually,
Sir,
Nikita is
it
from
is
my
like
team. He's
it
also over
is
here. I was having some network problem
okay,
today,
okay, sir.
so that's why I was unable to join. But I think Nikita, you can continue with this, and I'm going to take the next session. Okay. Have
Sure.
you started with this, Nikita, blockchain?
Yes, I did.
Okay. You start with that. Then the next session I'm going to take is about the cyber intelligence. Okay, fine.
Sure thing, yes.
Okay.
Yes, Alekha, please go ahead.
Yes, ma'am. Actually, as per the idea what we have regarding the security, we divide the data into different blocks and then we convert each block into a cryptic ledger and then we pass it through a key. And this, like in AES algorithm, AES 11, which is very famous right now, which has got into national award in 2011, we have divided the data into different blocks and each block is going through a cryptography. Either we will be using any cryptic method by inserting one key, a 16-digit key, and then we are going to divide the data. So as per the knowledge, what we have is like the data will be divided into different blocks. And then we are going to have it in the form of nodes and it is sent through a network. That is a cryptic data, like how we have it in the
Hmm.
bitcoins, cryptocurrencies, and all.
Okay.
This is only the basic knowledge what we have. But yes, I have come to know more about the blockchain security.
Okay, got it. Should I assume that everybody is on this page? Okay, no worries. Just to add whatever ma'am mentioned, okay. Uh, Blockchain comes under decentralized or distributed ledger technology. Distributed ledger technology. What happens here is there is not a single authority or architecture speaking as well. There is not a single server that we are relying on. Now we are relying on peer-to-peer networks. These are nothing but your nodes which are interconnected and the data is shared among them. How the data is secured? The data is secured using the cryptography hash. Cryptography where you use different algorithms like SHA-256, Usilians, your ED25519, ECDSA, all of these algorithms which are cryptographically hashed and the data is secured. Now, how the data that has been shared, which is synchronized within these nodes and are similar. So even if one node goes down, one peer goes down, we have multiple of them for us running. And how the trust is being used on this network is through the consensus mechanism, which we are going to look into it. So on a high level, when we talk about blockchain, it is nothing but your peer-to-peer network where your data is secured by cryptographically hashed and maintained by the consensus mechanism. That is what the blockchain is, where each of your transaction is again hashed and it is immutable. On your blockchain your data cannot be mutable. That is where your trust comes, that is where your transparency comes, where your data is immutable. Now, if this is the system, we are moving towards your web 2, we are moving to your toward moving outwards to your centralized system and towards the distributed systems. Again, if it is going to be hacked or if it is not secured, what are the three trilemmas? These are the basic three trilemmas. I think you must have seen in the last session, also in yesterday's session, your three CIA triads. First, it has to be confidential. Why it has to be confidential? Meaning that the data is only accessed by the required authority. That is where in the blockchain we use something called as rule based access. Second is the integrity. The data has to be the data is integrated because the data has to be should not be modified by any unauthorized commodity, by any unauthorized entity, and the data has to be available whenever required. Therefore we have a distributed system where we are not dependent on a single server, but we have now multiple servers, nodes, peers, which is making our data available. So all of these CIA triads are being fulfilled by the blockchain. And therefore the first main triad of the security is already been fulfilled by the blockchain fundamentals. I talked when we I talking about the blockchain consensus is where your data is being secured. That is where your data trust onto the blockchain comes in the picture. What is your consensus mechanism? Consensus mechanism is nothing but the data that is been secured by the this mechanism where a rule is followed making your data secured, where your data is been that can be trusted. Yes, is there a question? Okay. Anyway, so now in this system of distributed, why consensus mechanism is important? First thing we mentioned that it is not a centralized system, right? So there are people. So there are people, then how we are going to trust? There is not a centralized authority like when we talk about our transactions. We completely rely on the banks. Banks becomes a centralized system. Servers are maintained by the banks. Therefore, we are trusting the bank. But when we are moving towards the distributed system, the decentralized system, we don't have a centralized authority, not functionally, not architecturally. Then how we are going to trust any of these systems? There are different problems that can affect if we don't have a good trusted system. And therefore how this consensus mechanism is working is that these peers have the algorithms, the software that are working within themselves, and the transaction is such that it is a valid transaction, and therefore we are trusting this system. So basically, this consensus process enables your distributed participant to agree on a single trusted version of the ledger. Let's take an example in your classrooms only, correct? So in your classroom, there are two people who are taking the attendance. Maybe one person is saying that, the A person is present, while the second person who is attending says that, no, this person is not present. So whom do we actually trust the process? In that case, we allocate maybe a third person. Now, in this case, we would say we would take the majority of it. Like the maybe the third person says yes, this person is present. In that case, the majority of that the first person and the second person said yes, then you take that up, and that is how the multi we are working with different peers, where the majority who has given the transaction as a verified transaction, then that transaction is considered as a valid transaction onto the network, and the consensus mechanism, the consensus is at one page. In this case, the ledger, the transaction records, these are shared. So once the majority says that, this transaction is a valid transaction, this transaction is the verified one, then it is finalized onto the network and shared with everyone. Like in the classroom, once the person says that, this person is present, that is the final decision made, the consensus has been come together, then in the record, in the registry of the present, it goes, yes, this person is present. And that is how the consensus mechanism works. That is how, where all the peers come onto the same page, where all the peers have to come to the finality of the transaction. And that is how, after coming to the finality, where the majority comes into the picture, and that is the transaction is been getting finalized. Okay. I hope everybody has at least till now understood what is blockchain, what are the three major security threats that it is already trying to solve, and what is consensus mechanism. Can I get a thumbs up that everybody has understood these three topics at least? Okay, I got one. I'm open for the questions if you have any, because I can see only one hand raised. Do you want me any of the slide or any of the topic that to be covered again? Okay. Okay, I can see two of them, couple of them more. Okay, that I take that as a positive feedback and I'm moving forward. Correct. So in this consensus mechanism also, it is making us trust onto these peers. We have made this secured using the cryptography, but still there seems to be a problem if we don't have enough peers. So we in one of the leading blockchain, that is the Hedra blockchain, they have taken the inspiration from one of the problem which we call it as benzenite general problem. So it is a real life case that happened. So what happened was there was an emperor the benzenite emperor, who was in the war. So, and while going to the war, there are multiple generals that are allocated for certain group of people, for certain group of warriors. So, for these warriors that needs to be leaded, they have multiple generals, correct? So the emperor gave the decision, for the general A that we are good to defend now. You can move forward with our plan of attack. So, General A gave this message to General B, and General B said to General C, who was not loyal to the emperor, that gave the wrong information, that we are not ready for the attack. Even though General A was loyal, General B was not loyal. Therefore, the message that was supposed to go, that we are ready for the war was not, or for the attack was not conveyed, because the general B was not loyal. And therefore, of course, the even though the emperor had the resources, the right resources, but the communication was not proper, and therefore they lost the war. And therefore the communication gap that was there between these generals, even though the head was correct, cost them the loss of their war. And that was then again taking the name under this, the emperor, that is Benzonite. The problem that it has to that everyone has to be loyal, and a majority and a good communication comes should be into the picture. They talk this as Benzonite's general problem. To uh, to do this, we have a solution which is called as a Benzonite fault tolerance. A distributed system in Benzoyl tolerance continues to operate correctly even when some participants behave maliciously. So, for example, here is the example. We have a blockchain system of 7 nodes, out of which 2 nodes are not correct. They are malicious. They are faulty nodes. They are not giving the right data. But the 5 of them are giving the right data, and therefore, even though they are keep on giving the wrong data, they are still into the network. But the solution of this 5 of them is taken, and the network moves ahead. So there is a possibility maybe these 2 nodes are into the network. What is the problem with these? What can be the problem with this? Maybe they are not the updated nodes, therefore they are performing the wrong information. Maybe they are not online. Maybe they don't have enough network to keep up with the network. There is a possibility that they are actually knowingly giving us the wrong data. But in that case, we just ignore those wrong, faulty data, and we keep on moving. And that is one of the way that Hashgraph has taken up, where they are using this Banzan fault tolerance mechanism to make
That is
your
what I was telling. Shall I on
network
the
going.
camera and shall I eat?
Uh,
They won't. They
if
don't know my
if
name.
there is no question, I
It
request
will
everyone. It's
display
an humble request to mute
Shruti
yourself,
BL.
please.
Shruti BL, that's all.
Thank you. Okay, so Banzanite fault tolerance was one of the mechanism that is used. But apart from that, if you heard of one of the blockchain, that is your Bitcoin blockchain. I hope everybody has heard about Bitcoin blockchain, correct? So Bitcoin was the first blockchain where the cryptocurrency was used. It is also it is a first use case for the cryptocurrency. It is also the first use case of the blockchain, and that is actually where the inspiration also came from, because blockchain has these features like your transparency, your immutability. You are not dependent on any of the centralized authority, your trust, your security. From the inspiration of this only, we have multiple blockchains that are running, and apart from that, not just sticking with the cryptocurrency, we have multiple applications running. Now, this first blockchain, that is Bitcoin, what consensus that it used? It used proof of work. Okay. Now, in what happens? How does the proof of work works? In proof of work, the they every miner who is going to mine the block to create your blockchain, the consensus comes when they have to solve one arithmetic operation. Arithmetic operation, the simple example I'm giving is like your ax plus b equal to y. This is a very simple example that I'm giving. The arithmetic operation that is involved in these kinds of networks is a very complex arithmetic operation which is resolved. These peers are nothing but your machines. So these are converted. These are solved by the machine. So imagine the level of um, arithmetic operation they are resolving, and from that also all of these miners have to compete who is going to solve these arithmetic operation faster. That that person's uh, transaction verified would be taken into consideration. So this is one of the mechanism that is used in proof of work for your consensus mechanism. This is very much the secured way, very much the secured way of the consensus mechanism that is there till date. Because as and when the blockchain is scaling, uh, the difficulty level of arithmetic operation is also increasing, so it is adapting with the evolution. Anything that adapts with the evolution is going to be always going to be the best practice. But the major limitation for this is, first, it uses a lot of energy. As and when the blockchain is maturing, the arithmetic operation is getting on a difficulty level. Of course, you need a better computers, better processor computers to solve this arithmetic operation, and therefore it is going to it is going to consume lot of energy. It is going to commit a lot of carbon emission. So definitely it is high energy consumption. And as and when the network is also getting scaled, what happens is your arithmetic operation is getting higher, so the time at which the transactions are getting mined is getting very high. So when at the start of the network, when the transactions were happening in a second's time, now it is taking minutes to finalize your transaction, which is not at all good, where you have to millions of transactions you have to fulfill, therefore giving out the lower throughput. Very good example, but as and when the network matures, these are the major challenges that are being found. So we move towards the next consensus mechanism. Where we use most is used is proof of stake. So in all the blockchains, matured blockchains that you would see after Bitcoin, or like from like late 2020s, you would see the blockchains that are there, they have adapted to proof of stake, even Ethereum. So the second blockchain that is there in the market is the Ethereum, which allows you for your applications, blockchain applications running. So in this case, blockchains are the consensus mechanism used. So in Ethereum also previously, because the most efficient was proof of work, they used proof of work. But after you looking at these challenges in 2023, 2024, they had an update, and in that update they have completely changed their consensus mechanism, where we call it as proof of stake. Now in this case, what they are doing is, they the validators, they are going to stake the coins, meaning that whatever, if they want to be the part of the miners, they have to give some tokens, they have to stake some tokens as a liability, so that they don't ill perform any of the transactions. They are not wrongly doing any of the verification of the transaction. They stake the coins, they become the validators validates the blocks. After they validate the block in the right way, they get the rewards into the system, they get the rewards for their services. If by any chance, if anyone performs wrongly, if they give out the wrong validation of the transactions, in that case, whatever the staked amount is, that is there, the certain amount of percentage is deducted from their stake amount as the penalty for not performing
Take that. I'll
rightly
be
onto
going to
the
TMS
network.
tomorrow. No. Already it's registered in the Google Form for everything. Register?
uh Shruti ma'am, uh can you please mute yourself?
Yeah, done, madam. Muted.
Yeah, thank you so much. And if they find any malicious behavior, their stake is slashed. This is how they, even though they have moved from the most efficient and secured consensus mechanism, proof of stake, they are still, it is very much secured, very much efficient, bringing and coming after the limitations of the proof of work, where now it is energy efficient, it is faster, and it is scalable, and making it secured using the stake, proof of stake algorithm. So till now, we are almost end of the first uh, challenge, or first functional security part of the blockchain, that was the consensus. I hope everyone is following up with what is blockchain, how important is consensus mechanism. Until now we saw three types of consensus mechanism and how they are important for the security of the blockchain. And we saw about the benzonite fault tolerance, we saw proof of work, we saw proof of stake, and we are moving towards the delegated proof of stake. I hope everybody is following. If there are any questions, please put it in the chat, or if you want, you can unmute yourself and do it. Okay. Taking that as a positive, that everybody is on the same page, moving to the next consensus mechanism, that is delegated proof of stake. In the name itself, it suggests proof of stake. It is same that we have used in the previous slide, previously used. Here, there is just one that is delegated. Now, uh, instead of keeping the validators, certain group of them, what they are doing is they are randomly chosen for certain cycle of validating the transaction. Correct. So even if someone wants to change the transaction, if anyone tries to maliciously do it, there is still a process that they need to understand the pattern, they need to be in that system to understand the pattern, analyze the pattern, and then change the pattern. But what is happening is, until they understand this pattern, they analyze this pattern, they're already, maybe in the next cycle they might not get elected for the validation, so they are already out of that pattern system. So what is happening is they are randomly selecting these verifiers for a certain rounds where these is happening with the voting system. Whoever are the delegated validators, they validate the transactions that for that particular round, they get the reward and they are out of that system. They again goes into the queue where they have to pitch themselves or get in the queue to get elected again for the next validation. Until they come for the next validation, there is a lot of change onto the network, and again they have to start from the scratch in case they are they want to do any mishap, or they are in the not into the right attitude of validating the transactions. And that is the third way how they are trying to make the network secured using this consensus mechanism. We already talked about the header hash graph. In the header hash graph, along with the consensus mechanism of benzenite fault tolerance, that is not enough. What they are doing it is with the gossip protocol. Now there is no someone outside nodes that are going to give the information. What they are doing is whichever nodes that are truly done where they have finalized the transaction, they finalize this transaction and they use it, they pass this data using the gossip. How does the gossip work? I have this information. Do you have this information? A would ask B and C, do you have this information? No, take this information from me. B would go move forward and ask D and E to, if you have this information, take it. If you don't have it, take it from me. That is how they are working, and therefore the information that is coming to the end of the child node is coming from the right node that is been finalized during the benzenite fault tolerance. And that is how the transactions are being ledger is being updated onto the network. What they have done is the node itself, the main root process, the root nodes peers are fault into benzenite fault intolerant, and that is the source of information that is given to the child networks, the child leaf, the child peers that is into the network, making it a blockchain. Now everybody would be asking why we are talking so much about the consensus mechanism, correct? This is important because you have to understand when you are going to have your application running on any of the public blockchain, the first thing that you do in your solution is to choose the blockchain on which blockchain your application is going to be running in case you are using the public blockchain. And that is where your consensus mechanism comes in the picture. So when choosing the blockchain for your application, it is important that you choose the blockchain itself wisely, correctly secured blockchain, so that your half application is secured there and there itself. So that is important to look into the how you are making your blockchain secured. So till now we saw three majorly ones, that is proof of work, proof of stake, Hedra, hash graph, where in Hedra hash graph it is using benzenite fault tolerance, asynchronous benzenite fault tolerance. Just in the benzenite fault tolerance, it is using asynchronous, meaning that it is not waiting for the malicious one. It is continuously updating its network with the right information and without wait for the unlimited wait for the wrong ones. Hedra hash graph is a combination of your benzenite, asynchronous benzenite fault tolerance and the gossip protocol. uh, how you can choose the consensus first goes with the energy usage. So in proof of work definitely it is high, whereas in proof of stake it is low, and in hedra hash graph it is comparatively very low in the energy usage. Finality, how fast your transaction is getting finalized, that also is one of the way you are going, one of the factor you are going to use to finalize your network, to finalize your blockchain for your application. In case of proof of work, it is probabilistic. Like I mentioned, as and when your blockchain is going to scale, your the time at which the blocks are mined have from seconds have reached to minutes. It takes in Bitcoin, as if now, it takes 3 or more than 3 to 10 minutes to finalize a block. It is not anymore 3. If you look at the actual practicality of it, it is more than 5. Imagine a block is getting mined on 5, and or it's not only restricted to India. It is being used all over the globe. Imagine the user base, and it is taking 5 minutes for a block to mine. How much time we have to wait? It might take a day to complete our transaction, to look at the finality at R if everyone comes onto this network. And therefore we move to the proof of stake, where the transactions are happening in seconds. Hundreds of transactions are happening in seconds. Now Hedera Hashgraph is more faster, where thousands of transactions are happening per second. Throughput is low because the scalability is low. Proof of stake is moderate because the finality is moderate, whereas the finality is much faster, therefore the throughput is faster in Hedera. So it is inversely, finality and throughput is inversely proportional. Security, excellent security. Like I said, nothing like it, like the proof of work, but it has its own challenges. Therefore we move to the proof of stake. Till now there is still no problems, there are no threats that has been seen in this. So we are marking that it is still an excellent, excellent security wise. In header hash graph, of course, it is an excellent with an asynchronous, if you're using asynchronous Benzonet fault tolerance. Again, it is an evolving technology. So whatever we have right now, these are the best of them. You would also see, still you would see there are different blockchains. So for example, there is Polkadot, which is using the voting system for the consensus mechanism along with proof of stake. There is that too candle votings. There is Solana, which is using proof of history. Uh, there are blockchains which are using zero knowledge proofs. There are different consensus mechanism, but till date, where it has been efficient, it has been also scalable, it is secured. Along with security, all the other three trilemmas of blockchain and few triads of security that is most efficient found is in these three algorithms, in these three consensus mechanism. At the end of the day, nobody is going to say, this is the perfect of it. If it's a technology, if it's a machine, there are going to be threats, but we have to choose best of it and then practice on that which would be more secure for our applications. Okay, what are the attacks that are possible onto the consensus mechanism which would be a threat for this? One is the threats to consensus. This consensus mechanism purely dependent upon the peers and the majority of them giving the right transaction, keeping the ledger up to date. So the first is what we call is 51% attack. Whenever the finality of the transactions goes on to the majority percentage, so that would be 50-50 is the right one. If it goes 1% beyond that, there is a high threat that your transactions might be manipulated, because the majority of the validators are larger in case if they want to threat it. Second is the Sybil attack. One attacker creates many fake identities. What happens is, there is one person at the end who is maintaining the network, but what they are doing is it is that one person is maintaining all the peers. So in this case, why they have created a proof of stake? Even if it's a one person, he cannot have that much amount of cryptocurrency. It's a high amount of cryptocurrency that they have to stake. So they cannot stake so much on multiple accounts. Even if they create multiple accounts, multiple identities, they cannot have these many amount of tokens to be staked. So that is one of the way that the identities are faked, and that is where the Sybil attacks comes into the picture, and that is why the proof of stake comes a very handy and a very efficient way of doing it. Eclipse attack, where the right, if the majority again goes to the peers, what they do is they isolate the right peers. They don't get elected when the delegated process happens. They don't get elected because they get by the majority of the people, they get isolated. Maybe the validators are the right person, but their identity is being hacked. The identity attack, the identity is hacked. In case of Web3, in case of blockchain, the identity is like in your Web2, your identity is your mail IDs, right? In Web3, in blockchain, I think everybody is familiar. Their identity is nothing but the wallets, the accounts, which is a encrypted pair, a public key and private key. So if anybody takes a private key, they can have the identity taken by. So it is very important that you preserve your private key like anything. You should not be sharing it with anyone. It should not be stored anywhere haphazardly, because if anyone gets a hand of your private key, your wallet is as good as not yours. So these are the multiple security threats. Even though architecturally we have made everything possible to make it secure, there are still, these are the possibilities that the consensus mechanism can be at threat on this on these attributes. Okay, that completes our first part, and we are moving to the second part, which is actually your development and your operations of the onto the blockchain applications, where that is your smart contract. Any questions still here? Anyone? Should we move forward? Okay, so I'm moving towards the next part, that is smart contract. Does anyone know what is a smart contract? Okay. Uh, so in contract, in our day-to-day basis, you use this term. On a very layman language, it is a agreement between two parties, correct? Where the rules to be followed are being mentioned. If it goes as per, maybe there is a reward at the end. If it does not, if anybody does not follow these agreements, maybe there is a penalty, or there is some kind of punishment that has to be performed. It is in smart contract, it is same. It is an agreement between two parties, but now this, on the rules that you have been mentioned, that is executed by the machine, and therefore it is called a smart contract. On a very high level language, it is nothing but your business logic of your application, that is your blockchain, your decentralized app, D app, that is running. Your business logic of your application that is going to run onto the blockchain is nothing but your smart contract. So a smart contract is a self-executing program stored onto the blockchain that automatically enforces predefined rules. Now, what was the major difference in Web 2, that is your centralized system? User would interact with the UI, your server, your centralized system was there, that was connected to your database. Now we are moving towards the blockchain, your Web3 applications, your DApp applications. User is interacting with the smart contract, and this smart contract is been sitting onto your blockchain, where it is taking the features of blockchain, where it is secured by the consensus mechanism, it is trusted, it is transparent, it is immutable, it is secured by your cryptography hashing. That is the major difference that you see in Web 2 and Web 3 in case of your how your application is running. Now how what, and therefore all of your business logic is very much dependent upon your how secured your smart contract is. First pillar, we have made it strong by choosing the right blockchain where consensus mechanism is the major part of it. Now we are doing on to our development part, where a right requirement has to be fulfilled, it has to be designed. If it is designed correctly, it is developed correctly. After development, even till development, you are not coming across any threats, you don't see any loopholes. It has to be thoroughly tested to get your, so that your application is correctly running. There are third party security audits. You have to audit these smart contracts which are not biased by anyone. These are third party auditing that happens. And after that, you deploy it onto, it goes onto the deployment onto the public network, because blockchains are public network, you are not restricted to anyone. You monitor that contract, you monitor your application. It's not that deployment is done and done. You monitor that. Even if you come across any of how the application has to be run, if you still see any threats, you have an option that you can upgrade your contract by any threat that is there, and you can keep on improving. But of course, the major part is that if you come across the threat, you have to take care of that. Now few of these threats can also be securely done before it is already being deployed. In this life cycle only you can have this. What are the different attacks that are there? Redundancy attack. A malicious contract repeatedly calls a vulnerable function before the contract updates its internal state. They because it's a blockchain application which is running, their application also have many functions which works on the on continuous basis. There are functions that work onto which have high functions where they are interacting for the fundings, for the there are money involved here. So it is very important that you check for the redundancy checks, where your where your function is not called into the loops unless and until the right update is being done. So here is an example. Say for example, the withdrawal, anyone wants to withdraw the amount, the it has been initiated. After it has been initiated, it is been withdrawn. Okay, and again a withdraw function is been performed. But here what they should have done is, before after withdrawing, it has to be updated the balance, and then only the withdraw function has to be called. If it is not done rightly, there is a possibility that funds are drained and still you're calling the withdrawal function. So updating your internal state, updating your internal balance is important in this. So when you are interacting or when you are performing such kind of functions where you have the withdraw functionality, anything related to the funds, make sure you have checked for the retency checks, where you basically before withdrawing anything you keep on checking for the balance. Now this is a very famous DAO hack that happened on Ethereum, which is an example why where the smart contract was not right, and that is the first first and the last attack that happened also on Ethereum, which became the history, which later on was mentioned that it was not an attack on Ethereum. So what happened was, on Ethereum, one project, one application was deployed, one smart contract was deployed, where in this smart contract, the funds were being exchanged. In this, the attacker, because of this functionality, 60 million US dollars were at a loss. So they started taking to check what was investigating what was wrong. First, they concluded that the blockchain is not secure. This is at the very initial stage, that is 2016. In 2015, Ethereum was live. So just in a year, this happened. So everybody started questioning the Ethereum as a blockchain. After that, but when they investigated, it was not that the blockchain itself was unsecured or was wrong. It was the function inside this DAO application or DAO smart contract, which kept on impacting, or which kept on withdrawing this 60 million worth of points. And therefore it was concluded that the network was not at fault but the smart contract. So ultimately it goes back to how your requirement is, or how you have designed it, how you have developed it, how much rigorous testing you have done onto your smart contract to make it attack free. But when this investigation was happening, that time at the first they concluded that a it was a blockchain that is not secure. In this case, what happened was a fork was happening, so a new blockchain was created. And those who were like those who were said that no, Ethereum is not at fault, they were at the Ethereum community. Those who thought that this is a blockchain security point words, they shifted to the new blockchain, which we call in today's date is Ethereum Lite. Even though the main Ethereum, the final Ethereum, the first Ethereum that is still into the market on a very high rate, till date there are lakhs of applications that are running with no problem at all, no problem in there on the blockchain. The next very problem that is there when you are managing your smart contract is your overflow and underflow. You have to always check in your mathematical. Firstly, solidity language is the language that is being used to develop your smart contract, like your Python, Java, JavaScript. This is the language that is being used.
Sir, you're free, sir, now? I'll come.
This is the language that is used to develop your smart contract, which is again developed by Ethereum blockchain, but on all the blockchains you can see this working now. So always make sure that your integer arithmetic operations are not going underflow or overflow. For the safety purpose, they don't have your fractional integration or fractional calculations onto the Solidity language, because this applications are running on a very high funded project. The next is the best practices. There is libraries. There are multiple libraries which you can use. So directly, if you're not sure about your designing or of your development, blindly use the libraries that are created for this safety of the contracts, which is one of for these for arithmetic operation to make it safe. The library used is safe math, so you can use this library to make so that your arithmetic operations are safe. Next is access control vulnerabilities. Now these you are performing onto the public blockchain. So it is very important how you are going to perform your application. So you always have to make sure that your functions are RBAC. RBAC meaning role based access. Every function you have to mark, you have to mention who can from your application, which role can perform which functionality. Maybe few roles cannot perform the right operations, maybe few roles cannot even apply for the read operations. Take an example of your college. For example, in your college you are having an application where you are giving students the certificates, the degrees of that. So you have to make sure the administrator, the HODs of your college can only generate the certificate. These generation can only be done by the administrative of the Gopalan college. Students should only have the access for the reading operations. Like they can only read the certificates, they can download the certificates, they cannot generate the certificates, their degrees. So now here we have mentioned the roles. Students cannot, they can only read the degree. Administrator can generate the certificate, can modify the certificate. You likewise the generate function that you're calling in your application, you have to mention in the application that the administrative role can only do this. It is the most you have to do is you have to make sure you are giving the right operations to the right rules that has been mentioned. Delegated risks, delegate called risk. There is an important that you should always use uh, calls. So in that case, what happens is whenever you are going to update your contract, you have to link it to the previous one. It is important how you are managing the storage, because storage has your data which is publicly available. Using the right mapping, using the right call to the functions in this contract is therefore very important. Okay, this is a very important or very much used, very much seen attacks that is there, that is front running and MVP. Whenever the transaction it is happening onto the blockchain, but the transaction is created using the UI where the user's passwords, the user's private key is being used. What attacker is going to do, it is not checking your blockchain, it is not checking your smart contract. They are directly checking for the transactions that are going from your front end, from your web into the into the pools where these transactions are first filled, and then it is getting distributed to the validators. What attacker do is they enter this meme pool and they finalize, or they might add something data there, or they might prioritize the fees there and ask for the transaction to be used on a faster rate. Once they perform, once they check for the pattern, once they understand the pattern, it becomes very easy for them to attack the action. So it is very important that how your transactions meme pool is also being managed. Now in this case, what are the tools that you have to look for? In this case, what kind of wallet you are using, how that wallet is maintained. So MetaMask is one of the most used, most secure till date. But apart from MetaMask, there are also n number of wallets. Of course, your hard wallet is the uh, first most secured wallet that is there into the market. But if you don't want to use hard wallet, if you want to go for the digitalized wallets, your web based wallets, your phone based wallets, MetaMask is the most secured one. Coming from the digital hard wallet, there is the first most efficient one, then into the digital one, these are there. So you also have to make sure when you are interacting, when web3 interaction happen, what kind of libraries you are using, whether it is an ether.js, whether it is a web3.js, if you are using any third party libraries also to integrate your front end to the blockchain for your transaction purposes, how they are maintaining the data, how they are maintaining and managing the pools, that is also important how you're going to do it. So you have to make sure that you're aware about your front running and MVP this thing. Oracle manipulation. There are multiple platforms. For example, a prediction market. In prediction market, what happens is prediction market, the data, blockchain doesn't have any data. Blockchain doesn't have access to outside world data. It has to give some input to perform its functionality. There are in the prediction markets, the prediction or the result of the functionality depend upon the outside world. So what happens is there are these servers who is going to give the data to the blockchain to perform some functionality. So it has to be made sure that your, and this machines that is going to give the data is nothing but your oracles, what we call in the terms of the technical term is oracle. So oracle should not have the manipulated data. If the data is manipulated in the oracle itself, it doesn't matter how secured your smart contract is, how secured your blockchain is, it is going to give you the wrong output only. To get an example of this, there is a platform called as Mango Oracle. Okay, so it's a prediction market. So it was also, it was not a very big case, it was also a testing or the protocol that is they were performing. So this was a prediction market, and it was a simple prediction that they did was like whether tomorrow it is going to rain or not. And what they did was they manipulated the data into the oracle, where they gave 51% that it rained for, and 50 point something they gave that it didn't rain, where in actuality it rained. But ultimately what oracle gave was majority of that it rained. So ultimately the output given, the predicted result given by the blockchain was it rained. So it is important how you are using your oracles. What is the best practice you can do is, the best practice you can do is you can use your oracles that are again decentralized. It is not filled by, it is not a centralized oracle, it is not a centralized servers. You give decentralized servers, or you give multiple servers to choose from, and the best one, the majority of them can have the right practice. So the, if you want to avoid oracle manipulation, the best practice is you use the decentralized distribute oracles. Yeah. Denial of service. When you are developing your smart contract, that time what you do is you make sure knowingly or unknowingly, and it only happens when you have well tested it, that any of your functions doesn't go in infinite loops. You can write loops, you can have your conditions in solidity language, you can have your while loops, you can have your for loops, but make sure that it doesn't go into the infinite loops, because ultimately it is going to use the gas, and gas exhaustion is one of the major scenes that are being seen into the while executing the smart contract. So whenever you are creating these, make sure that you don't have infinite loop going on. First, it is expensive, of course, and your application is going to get stuck. And how what are the best prevention? First, of course, you should not have the unbounded loops. There has to be a good checks of error, and there has to be minimal dependencies onto how these onto the external data that is being there. And how you are going to come across this is with a thorough testing, that you do multiple rounds of testing. Okay, the next one is timestamp dependency. Uh, so in timestamp dependency, what happens is many of the smart contracts we do with the timestamp, and we assume that the timestamp that is there onto the blockchain is perfectly matched with our assumption. But in reality, we always see that as per the scalability and throughput, there is a slight, you would see a slight difference into the time that is being used, the timestamp that is being used. So it is bestly used is you don't rely onto this timestamps. If it is highly secure, questionable, you don't rely on these. You directly match the timestamp with the validator's timestamp, because validators is actually who is maintaining the network. If you match your time as per the validators, there is high possibility that your time related, timestamp related functions are going to be performed very smoothly. We do take care of all of these attack or the threads that is there, correct? We took care of the retency, we took care of the timestamp, we took care of the loopholes. All of this has to be taken care of, yes, but it is going to be finalized with all of these SDL cycles that are there, right requirements, right design, secure coding, with all this taking into consideration, testing, thorough testing. You have to do your unit testing, you have to do your local testing, you have to do your testing onto the test networks. You have to audit your smart contracts using the third party auditors, where at the end these third party auditors give you a thorough report which functionality in, even they give us such a thorough reporting that which line of code is much vulnerable, what are the changes that it has to be performed, does it match any of the compliances that has to be matched. So it is a good practice to give it to the third parties like OpenZappLane, there is CyberSec. All of these, two to three of them are renowned into the market, so you have to trust these third parties and give your audit your smart contract before going on to the deployment. Then yes, your smart contracts get secured with this auditing, but also it gives you the trust into your user base by showcasing that your smart contract is being audited by this standard, this third party which has their own standards into the market. The last point here is how you're going to secure your this thing is by using the open sapling libraries. So this is again a very secured library that is there. So it is always guided, it is always motivated to the for the developers to not use everything from scratch. If you find any of the libraries that are already there, if it is well trusted, well thoroughly used by other applications, to use those, what happens is that there is a less possibility of threats and security purposes. Your development is easier. Even if you might have missed any of the security threats, they are already been carried, they are already been taken care by this library. So always, if there is a library renowned, these libraries also has to be secured, these libraries also has to be maintained, these library also has to be secured, where they all these libraries also mention their reports that has been come, so you can use these libraries. Many of the tokenization application that you see in the market are also not built from scratch, they also use this open sapling library. So it is nothing wrong to use the ready-made code that is already there. It is actually a smart choice on a long run, in case of your security threats and all of that, to use the well-tested libraries that are already being there. Okay, I had couple of slides more, but not very important one. I think we covered all the important points. And as time is up, we can take 2 to 3 minutes if there are any questions. uh, are there any questions? You can put it in the chat. You can unmute yourself and ask right away.
Ma'am, you have said about the third party secure tools, one being
Correct.
what is that?
Open Zeppelin.
OpenZap, that is a library, right, ma'am?
Yes, but they also
Open
have a
Zeppelin is
service for the auditing of the smart contracts.
okay. You have used another tool name like CodeSec or something. I don't remember.
Certic. Yes.
Ceretic.
Yes.
Okay. Can I have that spelling, ma'am?
Yes. I am just typing it right
Okay,
now.
okay. Thank you. Thank you, ma'am. Thank you.
The next session is at 12 o'clock, right?
Yes, sir. Yes, sir. At
Yes,
12
yes,
o'clock.
sir.
Okay. Okay, fine. So that will be my session. So I'm going to cover that session, and the topic will be threat intelligence and predictive cyber defense. Okay, so meet you at 12 o'clock.
Sure, sir. Thank you.
I think Amar Sri has some question, Nikita, so you can address that.
Okay.
No, sir, no questions.
Okay. That would be all. Thank you so much. Thank you
Okay,
for being such a
so let's
wonderful
catch up at 12 o'clock.
participants.
Thank you. Bye.
Yeah. Thank you. Bye.
Thank you so much, Nikita ma'am, for joining us today. I hope it is very helpful session for all of us. Thank you so much, ma'am. Have a good day.
Yeah. Thank you. Happy learning.
Thank you. So, dear all, we'll have a short break till 12 o'clock. Please join after that. Thank you.
Hello.
Hi, sir. Good afternoon.
Good afternoon. So,
Yeah.
Sweta, let me know
Eh,
when we are going to start. Okay.
Sir, we can go to start now, sir.
Okay.
Yeah, all are joined already. So you can start the session, sir.
Okay. Let me know when my screen is visible to you all.
Yes, sir, it is visible.
Yes,
Okay.
yes.
Just give me a sec.
Mhm.
Just give me a second.
Okay. Okay.
So let everyone settle down. Then I'm going to start the session.
Yes.
Okay.
Yes. Sir.
Yeah. Jasmine Lobo has raised her hand. Can you check, Sweta? Hello, Sweta.
Yes, sir. Yes, sir. I
Am I
will.
audible?
Yes, sir. I'm. Yeah.
Yeah, yeah.
Yeah, Jasmine Lobo, you have any question? Please unmute yourself and you can talk. Hope by mistake you have raised your hand. I will lower your hand. If anything is there, you can again raise your
Okay.
hand.
So, okay. So I think we are good to start. Right. So, good afternoon, everyone, and welcome to the session of threat intelligence and predictive cyber defense. Just give me a second. Okay. So this session is going to be of 1 hour. Yesterday we have talked about the cyber attack, what type of cyber attack, why, what is a cyber attack is all about, and different type of cyber attack which took place, right? So that we have covered yesterday in my session. My name is Amit Chandra, who have joined now today. Let me give my short introduction to all of you. My name is Amit Chandra. I am having 18 years of experience into the IT industry. I worked for multiple companies, IBM, Entity Data, ENY, Patni Computer System. I have been working in blockchain and cyber security for past 6 to 7 years. And it's a great privilege that I am today over here to give you one session on the cyber security and how you so that you will have the awareness. So cyber security is basically you have to understand that it's a kind of practice, and based on that practice, how effectively you will be able to manage for any kind of unwanted or unauthorized person to breach your premises or breach your house. We have seen that about the importance of data. Yesterday, I've talked about the importance of data. So it's something that nowadays there are so many data. We log into a website, we do search, all the logs are getting generated, whether it is through the cookies or whether it is inside the server of the organization whose platform we are using. And nowadays, data has become a very important piece of activity. So if an unauthorized person access those data, I think I would request everyone to please go on mute because it's create a disturbance while giving the session.
ಟಿಕೆಟ್ ಒಂದು ಸಿಗ್ತಾ ಇಲ್ಲ ಸೇವ್ ಮಾಡ್ಬೋದಾ
Hello. Sweta, can you please check that one?
Yes, sir. Yes, sir. I'm on. By mistake, it seems. I
Yeah,
was.
yeah. So because sorry to say, but it's created disturbance in order to present the
Yeah.
things. Yeah.
Yes, I will disable it.
Yes, where I was that yesterday I talked about the data, how the data is getting managed into different type of format in different type of servers, whether it is database, whether it is a file system, whether it is in a kind of blockchain, and if anyone unauthorized person get an access to the data, then how much damage it can do to the organization. I have given an example of that also. Few of the cases which I have given is about the Aadhaar card, where an unauthorized person able to access the UIDI server, and that could damage the reputation of the organization itself. Along with that, AIMS hospital, I've given the example that how the server is down and the manual activity has been done. I've also given an example that how a hacker hacked the entire system and asked for the ransom. So basically, those kind of attacks which has happened, and the organization are continuously monitoring the different type of threat which are going on into the web world. Okay, and whether it is through the news, whether it is through the dark web, whether it is through any kind of platform, they keep on monitoring all those kind of threat and try to implement all those things into their existing organizations so that the people will be aware of that. I'm also going to show you one of a thread which I have recently received, and I have reported to my information security team. Okay, so that will be a good example for you and a live example. But before we can go ahead with that particular mail which I will show you, let's think of the threat intelligence and predictive cyber defense, which is our topic. So what is a threat intelligence and predictive cyber defense? The threat intelligence is basically looking into the various kind of pattern, looking into the various kind of tools, the various kind of practices which are being used by this cyber theft. A predictive analysis has been done that how to stop that, man. So this particular topic is based on that only, that what kind of intelligence an organization is going to follow, and based on that intelligence, with the help of modern technology, how a predictive analysis will be done in order to defense the cyber attack. So let's begin with our first slide. And in that first slide today, I have made make that slide more a kind of storytelling PPT, so that it will be easy for you to understand the user flow. So first of all is the threat intelligence and predictive cyber defense. So what is a threat intelligence? It is based on the evidence and the knowledge of the attacker. It means that keep on monitoring the attacker work ethics, and what type of tools they are using, what type of infrastructure they are targeting, what are the target audience, what are the tactics they are using, and this could be collected from various platform, that is dark web forum, malware analysis, and global sensor network. So basically, threat analysis is who, what, and how. This should answer the question that who is just stealing the data, how, what type of data they are stealing, and how they are stealing. Whereas the predictive cyber defense is an intelligence which works on based on this data and gives an kind of analytics and a kind of analytics tools to showcase you, to present it in a structured manner, that these are the pattern based on which the attack are being happening, and what is going to be happen next. Okay, what next attack it is going to be happen, and where it is going to be acted, what we are going to supposed to do on that. Okay, so let's take an example of a simple story in this particular diagram, where you can see that the intelligence team, that is the cyber security team which the organization has, they noticed that cyber criminal have created a fake website that looks similar to the bank website. Okay, so they keep on monitoring the particular platform of the organization, and also to the social media, and they keep on monitoring that one. And based on that, the expert of that cybersecurity team analyze the pattern and discover that based on that particular website, fake of website, attacker are trying to gather the information from the organization, the pattern of information which they are trying to gather. It's a kind of either they are using a phishing email for that and gather the email ID of the users, and based on that they did some kind of predicting analytics, what type of past attack which has been done, and they also analyze that once they capture all this kind of information, what type of attack they do, whether they do attack on the financial department, or whether they do attack on the certificate end, or whether they do the attack on the personal information of the user. So based on that, they decide on the prediction, that what if this kind of attack is going to be happen, then what are the critical department which is going to be impacted. So from 1 to 3, what comes to know is that first of all, uh, the experts, the cybersecurity team keep on monitoring the social media platform. They monitoring the Web3 world, and they try to see that what type of phishing activity which is going on, and based on that they analyze that if this is a cyber attack, then what type of information it is gathering, and whether the attack is from the email, SMS, WhatsApp, what type of attack it is. Once the analysis is being done, then they predict that once this information is being scattered into the various kind of platform, then what type of information they gather, whether it is the IP address, whether it is the user ID password, whether it is any kind of personal information, and particularly what department they are targeting. Okay. So if they are targeting, suppose a finance department, then the foremost work of that security team is to alert the finance department and stating that if you receive any kind of email, any kind of fake website, then try to block that one, or they themselves block those kind of website to attack the financial department. So basically it works on three model. One is signal, analysis, prediction, and action. Okay, so basically in every stages you can see that the experts spot the early sign awareness in the first defense. Then they understand the pattern and gain the knowledge into the more clarity that what type of attack it is. Based on the knowledge and clarity of the attack, they predict that what type of department it is going to be impact the most, the level of risk it is going to create, and then they perform the action. So this is how a threat intelligence predictive cyber defense perform, and that is used to stop the attack before it happened. This could be applicable to any kind of organization, whether it is bank, university, whether it is any private agency, it will work the same. Then what are the four level of threat intelligence? Means at the various level of the organization, this kind of intelligence happen, where you will be able to predict that what type of cyber attack it is. First of all is the strategic level. Okay. So it gives a big picture, and it gives the risk that is going to be associated with the leadership role. Okay. So it means that the management will keep on asking that if such kind of attack is going to happen, then what is the ransom kind of attack, means whether it is a kind of any kind of ransom where the ransom is to be paid, because that is most worried for from the management side, if they have to pay anything to the hacker. Okay, then it comes to the tactical, where it's more about the architecture. Okay, it means that if any kind of email is getting circulated, and based on email, they are stealing the password of the particular employee. So it is more into a kind of a tactical technique, try to understand the architecture level of the attack, techniques, procedure, what the cyber theft are using. The third one is the operational one. Okay, so in this, they're just checking that if it is a phishing attack, then whether it is targeting on the payment team this week. That kind of prediction need to be done, that well how it is going to be did. And next one is the technical one. It is more into a kind of technical thing, where the malicious file hashes and domain, what type of reading it is getting done, means at the code level what type of impact it is going to be performed. So these are the four labels which a threat intelligence happen: strategic, tactical, operational, and technical. Started with the management, and it goes to the more deeper level to the technical side. Now, let's take an example of indicator of compromise. So what are the things which can be compromised at the department level, which need to be made sure? First of all is the file hash. Okay, we know that the files are getting stored into our servers, and a particular hash is being generated. So with the help of fake domain or a unique file, digital fingerprints can be created. And if the hash get matches, then it will be dangerous then there is a malicious IP address, fake domain, and behavior. In the right hand side, I have just given an storytelling for a bank, where how a bank stop a phishing attack. Okay, so first of all, the trap is set. An employee receive an email that looks genuine. I'm going to show this example to you. I have also received yesterday only, I have received a mail from my leadership about this kind of attack and how I have handled that one. I will let you know. So first of all, the phisher is going to trap you by sending you an email. Then the employee click on the link, and once you click on the link, then it takes you to a fake website. Okay. Once you go to that fake website, your credential will be stolen, and the employee device will be connected to their server, theft server. There are two options over here. First of all, your credential will be stolen. Next, the attacker can give you some files which will be automatically downloaded into your background, and it will perform an operation into a server. And what will happen that it from yours for your machine, it can attack to the server of the organization, and several files and and backup will get disabled. Okay. So in order to prevent this one, the security team will continuously monitor this one. Okay, the tool detect the IOC, the SOC team take action, and the attack is stopped before any major damage happens. Because if it passes through 1 to 5, then they it directly impact the system. So it's very important that there should be an awareness that at least from 1 to 4, there will be a kind of awareness to the system. So the four key indicator of compromises will be the fake domain. Okay, so you will be receiving a fake domain. The basically the website will be same kind of bank or any kind of e-commerce portal, any kind of firm. It will be looking similar to then the IP address will be used by the attacker to host the malware command servers, and file hash, they are going to generate a unique digital footprint of a malicious file, and if it will be compared with the file which will be in the system, and if it matches, then the file will get encrypted. Suspicious behavior. Okay, so mass file encryption at 2 p.m. it will encrypt the entire file system of the entire server. Where intelligence comes from. So how you will understand about all these kind of patterns, that this kind of activities which are going on, and you have to be very much careful. So there is a cert.in advisors and national alert. It's an official website. I'm going to give you a detail about this. It's an official website where you can go through and you can look into that what type of attack which are getting. You can also go through the commercial and often open threat feeds. Okay, you can. I will not suggest. You can go to the open source information. Okay, sector sharing. So all these sectors or all this medium you can go through and check for what type of attack which are new and which are there. So let me show you one example of an cyber attack which I just came to know. Okay, just give me a second. Okay. Just Just hold on for a minute. I need to check that how I have reported that one. Okay. So see, uh, this is the mail which I have received yesterday, and uh, in my personal email ID, and so this is the mail. Okay. So I think it is visible to you all, this mail. Let me open it. So Sweta, can you confirm, is it visible?
Yes, sir. Yes, sir. It is visible.
Okay. So as you know that we are from IDS, and I have received one mail in my personal email ID from my CEO. The attacker is supposed to give the name of our CEO. Okay, and it gives a sense of urgency to me, saying that hello Amit, acknowledge if you receive my text. Okay. So when I looked into this mail, I found it very suspicious. I just checked the from email ID, and you can see that from email ID h3685505@gmail.com, which is a very suspicious email ID. So what happened? I looked into that. I haven't clicked any kind of link. I've taken the screenshot. Once I have taken the screenshot of this, I reported it to my information security team. Okay. So in that I inform my information security team that, dear information security team, I received an email from an unknown sender with the name of Sudarshan requesting me to acknowledge his receipt of my text message. The email came to my personal email ID. The email appears suspicious and may be phishing or social engineering attempt. Please inform the team members. These are the details I have given. I have not responded to the email and would appreciate it. So I immediately informed my information security team. My information security team reported that, thank you for reporting this suspicious email and not interacting with it. We have noted your report and currently investigation this part of our ongoing COEA. Please retain the email for now as it may be required for further analysis. If possible, please share the original email in .eml format as it will help us to perform detailed investigation. So now he has that information security team told me the steps where I can download .eml file and I can share you with that. Now, the next step which the information security team will do, I will show you that one as well. See, based on that, the information security team has sent a mail to all the employees of our company stating that urgent security notice fraudulent email targeting IDS employee, where it has mentioned that all the aspect, it is something an old one. Okay, so as you know that as a part of an organization we get a lot of this kind of attack happening and we have to be very much careful. Okay, so this is how the particular things happened. Okay, where now what happened that now the action item is that based on that email file which I'm going to share with my information security team, they will put it into their tool, and in case any kind of attack is going to be happen with some same kind of IP address or any kind of subject line, it is going to capture those particular pattern, and it will just stop those particular email there itself. So this is how the cyber attack happened into an organization. So, and you have to be very much careful when you are going to perform your day-to-day activity. Okay. I hope this example clears you that what type of attack happen in our day-to-day regular basis when we do our work. So when you receive such kind of email, suspicious email, just check the sender email ID. Don't click on any kind of link. Okay, before that, take a screenshot of that, notify to your information security team, and ask them to take the action, and also inform your colleagues that this kind of attack, if you are receiving any kind of email with this email ID, then immediately report it to the information security team and they are going to take an action. So the example which I have shown you is what you can see in this particular screen, where in the first one, considering myself, an employee receive an email that looked genuine, right? I received an email which looks genuine to me. Then the employee clicked the link and is taken to a fake website. There was a link, but I haven't clicked that one. Okay, I haven't clicked that one. In fact, I've taken a screenshot of that. So I haven't performed the second one, but in case if anyone is not aware, they will perform the second one, right? Then when they click on that particular link, the information will be stolen. Okay, suppose you click that link, it will go to a page, and your information will, whatever your cookies information, they are going to store that one with all the credential. It is going to store that. I, Either they will inform the information will be stolen, or they will install some kind of files into your system which will automatically perform the operation, and you will be seeing that at particular moment some suspicious thing is happening into your machine. And in case you are updating your information security team, then they at that moment only they will stop that those things. How they are going to stop when the attack has already been happened? Either they will ask you to shut down your machine, okay, and do the format of your machine, or if that has injected into the server, then they will run some antivirus and stop that, or they will either stop the server itself. So this type of things they are going to perform. Okay. Let's move to the next slide, which is a MAT3 attack framework. Okay, what is this framework? So basically, as we know that the best way to prevent cyber attack is to understand and have a knowledge that what type of attack it is going to be happen. Okay, so basically, this MAT3 attack framework is a global recognized knowledge base. Okay, it's a kind of knowledge base, and with that document all the new kind of attack which basically happens in an organization. So by going through this Metri attack, the information security team will able to understand that what type of attack, new attack, which are there into the market, and they can design a best practice, and they can inform their employees that not to uh, not to get into the trap of those kind of attacks. So basically, the information security team or organization use this particular framework to understand the attacker behavior, identify that whether there is any security gap into the existing system, and based on that improve the defense. If they see that okay, this kind of new attack has happened, they can either upgrade their software, and they will ask all the employee or the user to update their software. That's why we nowadays we see lot of messages coming that to update the software. Okay, that is only because they have introduced some kind of code in that which will prevent you from those kind of attacks. So Met3 attack is a kind of Google map for cyber attack. Okay, it shows that how hacker attack. Okay, what step they follow and where organization can stop them. So these three questions it gives answer to. So basically how why it is going to be useful. So instead of asking the information security team that can we stop hacker, okay, it helps the organization to ask that can we detect phishing email, can we detect malware execution, can we detect malware persistence, and can we detect data leaving our network. Okay, so if we are not able to answer all these four questions, then there is a security gap. For example, in my case, it was a phishing email which I have received to my personal email ID. Okay, so the answer should be: can we stop such kind of phishing email which are coming to my personal email ID? So if the answer is that yes, then the security is foolproof. But if the answer is no, then there is a gap, and the security team has to take care of that. Now, in the right hand side, it's a kind of story that how hacker think, so we can stop them. So basically, when we talk about cyber attack, it's basically a kind of it's a kind of crime, right? So we have to think as a kind of policeman that how we can stop those kind of attack. So there are common pattern which we have to look into with this kind of framework. So based on the new attack which will come or just registered into this framework, the cybersecurity team can discuss that what happened. So what happened? It means that what type of attack it is. Okay, whether it is coming through an fake email, whether it is coming through an email initial message, or whether it is coming from an SMS or WhatsApp. So and what type of action the employee are doing or the users are doing. Okay, so it's basically an initial access, and the technique is for this example, it's all about the attachment and the email from the suspicious sender. Next one is the execution. Okay. So once the employee receives such kind of email, what the action it perform, what it does. So normally what the employee do is that either they click the link or they will open the particular file. So if they open the click, what if they open that link, then whether it is just capturing the IP address and the cookies of the particular user, or if it is a file, then whether it is getting downloaded into the machine of the user. Then the other third question is that persistence. It means that suppose that attack has been happened and we stop the server, or we restart the machine. So still the attacker are having the access to that particular machine, then that is the third point, is that need to be see that whether the attack is continuously happening or whether the attack get discontinued when the link is stopped, okay, or when the machine is getting stopped. That's why you have seen that whenever any kind of attack happened, then the server gets stopped. Okay, because they don't want that the more kind of attack it is going to be happen, and that's why they stop those server. That is the first and foremost best practice, is to stop the server, immediately stop the server and make it inaccessible to the attacker. Finally, the attacker secretly upload customer data to his own server, that I have already explained. Okay. So basically, this particular Met3 attack framework is a kind of repository based or a document based, from where you will be able to know what type of new attack which are coming into the market. Okay. And how to prevent those, so that your security team will learn from those particular attack, and they will take all the preventive action into your organization. Okay, sorry. Now from reactive to predictive defense. So as of now, we have seen that we have just understood the pattern of the particular attacker, and based on that, what we find out that not to click the link and all those kind of things. Okay, but we have to be very much predictive defense. It means that we have to at the initial level only, we have to decide that based on that pattern, what defensive mechanism we are going to use. Okay, so first of all, there are various way of doing that one. We can install AI ML. For nowadays, it's all about AI. AI just scan the entire database and see that whether there is any kind of suspicious things are there, and it can inform you. Earlier, now we also have an antivirus which keep on checking the database and see that is there any kind of new attack happened or not. If it is not updated, then update your antivirus also. Okay, so continuously searching that that whether your server is exposed to the new system or not. We have seen in the organization that I was a part of IBM ENY, and we have seen that whenever they used to keep on sending a mail that not to use the social media platform, and sometimes they stop those social media platform, whether it is the Facebook, whether it is YouTube or something like that, so that the attack, the more secure they make the, that's why when we take an example of Android and iPhone is more secure, because in iPhone mobile it's very difficult that you, in Android, what happened that you can install anything into your mobile device, but in iPhone you will not able to do that one. Okay, so the more firewall you make, or more less exposure you are to the outer world, the more secure you are. That is the difference between Android and iPhone. That is the difference between Windows and the Linux operating system. Windows is something user interface operating system, where you will be able to perform all the things as a user within a click. But Linux is more into a kind of a command line kind of operating system. It is still an UI, but it is not that much user friendly. That's why it is more secure than Windows. Okay, the more exposed you have to the outer world, the less attack it is going to be happen into your system. Okay. So what is a threat intelligence life cycle? So threat intelligence life cycle is a step-by-step process that is used to identify, understand, share, and respond to the cyber threat before they cause damage. Okay, so that is the basically a life cycle, that once we have any kind of threat, how we are going to react on that. So in this diagram, I'm trying to explain you that in an organization, how this particular life cycle happens. Okay, so if you could look into the first step, it is the direction. Okay, which talks about that what do we want to know. Okay, so the IT head can ask that to resources that whether any new phishing attack are targeting educational institute. So the IT head, who is the security head of a company, he can ask his employees who are into the security team that we find out that whether there is any phishing attack which are going on into the educational institute. Then they will use different kind of framework. One of the framework I already mentioned is the Maitre. They will go into that framework. They will gather the information from that framework. They will also look into the social media. Okay, they will see that is there any kind of information which are getting circulated or any kind of new cyber attack which is happening for the universities. So they will collect the information. Once that data is being collected, obviously those data which is going to be collected from the different sources, it will be into an unstructured manner. It will not be in a structured manner. So they will collect all the data unstructured logs or different kind of logs and all those things they are going to collect it, and then they are going to process the data. So that raw data, they are going to process the data to make it as a structured data. So for this, the AI tool is going to help them. Nowadays, AI, so the AI tools will help them. Earlier, it was different kind of platform tools where you put the data, it will automate that one, and it will give you a report on that. Okay, so it will process the data. Once the data is processed, you understand about the data. The team will analyze the data and understand that what type of threat it is, what it is doing, what impact it has, and how the users are getting into the trap of such kind of attack. Okay, so once they have the understanding of this, the thread, analyze the study and process the data, find the pattern, all those pattern, then the security team is going to share those particular analysis or the pattern with all the employees or the student or the university people, that this kind of attack which is coming on with this email ID, you don't have to click that one. Once you receive this kind of email ID, please report it directly to the IT security team. And once that is being done, then they take the feedback and they update their system based on that. So this is how the threat intelligence lifecycle goes on. And I have also shown you one example that I receive a phishing attack, and what action I have taken and what action the security team has been taken. So from 1 to 6, I have given you a live example. Okay, that what type of attack it is going to be happen. So this is something about the threat intelligence life cycle. Now let's take an example of what OSINT reveals about a college. Okay, so what is an OSINT? It's an open source intelligence, and it's a process of collecting and analyzing public available information from the internet and other source. So in this example also, if you see that the information is getting collected from those particular platforms only. Okay, that step 2. Okay, so it's collected from the college website, full day staff directory with name, designation, email pattern, tender document, social media, job posting, all those things are being analyzed thoroughly, and 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 based on that the processing is being done and the analysis is being done, that what kind of threat it is going to be happen. Okay, the other one is the credential leak and the dark web. Okay, credential leak, that if sometimes some kind of breach is going to be happen or the database breach is going to be happen, then what type of information it is going to be stolen, whether it is the email, password, phone number, and whether it is getting traded into the dark web market or not, and how many days it is getting traded. So all these kind of predictive analysis is to be performed. uh, Monitoring this market will also help to identify that how much time it take to go to this kind of information to the market, and how much is the cost of selling those kind of credentials. So you have to be into a 360-degree mode of looking into all kind of medium and platform where this kind of things are happening and misused. Okay, so check exposure. You can check into the exposure that, for example, I've given an example in this that I have been .com, see which breach include your email, action it. once that act on it, force password reset and email multi-factor authentication. It means that nowadays, yesterday only I told you that nowadays putting user ID and email ID and password is not the one method of authentication. There is another method of authentication is that once you pass this, then you have to give an OTP of that, or there is a face authentication you have to give, and based on that only you are going to be login. So the number of number of authentication it will be there, it will be more difficult to breach the firewall. So when we use any kind of website, we give our login ID and password. So what is that? It's basically a gateway. It's basically a gateway for the server to understand that who you are and whether you have the access for this application or not. And if you have the access, then what type of uh, role and responsibility has been assigned to you. Okay. It is not like that if you are a user and you will be able to perform the administrative work of the particular application. Okay. So if you are able to do the administrative work of the particular application, then also it's a kind of security breach, right? So all this kind of validation, authentication need to be there in place into the application when you develop that one. Apart from that, what the cyber attack is going to do for your application, that is also you have to take care of. But before that, you have to make your application that much secure that at least no one will able to enter without the permission. Okay. Now let's take an example of a threat hunt step by step. Okay. So this is something that that intelligence, right? Threat advisor group is abusing RDP. It means that we have an access to our remote desktop, and from that remote desktop, someone is trying to enter to the education network. Okay, so 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 how the action it will be if we are affected? Means suppose our RDP login are from the unfamiliar IP address outside our work, then we have to query that this kind of things when it has happened in the last 90 days, 30 days, then we have to understand the pattern. Okay. For example, if some threat is happening and someone is trying to access our RDP, and we take the log and we can see that from the log, the IT team, the security team will see from the log that, okay, this kind of attack is happening at the regular interval, then the pattern will be defined at what level, okay, at what time the RDP login is happening, and what is the, and this pattern will come from 30 days, 60 days, or 90 days of log. Okay. So after you have that particular information that at this particular time in this 90 days, this kind of attack is happening, then the next thing is to find out that whether it is from the one IP address or it is from the multiple IP address. Okay. Then if it is a multiple IP address, then the security team will stop those multiple IP address to access that particular server, or they will disable that account. Okay. Close the RDP to the internet and start in reviewing that how to stop that. Okay. That is how the IT team or the security team works on. So what I have explained over here is that the security team keep on keep on looking into the logs of your platform, the university platform or the organization platform, whatever the access which you are doing, they keep on looking into that. They are searching for a common pattern. Based on that common pattern, they identify that what type of risk it is going to generate. Based on that risk, they decide that if how to stop this particular, what is the common pattern it is being used. And once they stop that one, once they identified that, okay, these are the common pattern because of which the impact is happening into the server, the first and foremost thing they will do is that first of all they will down the server, and then they will analyze that whether they have to disable all this IP address or what type of preventive measures they have to take into the system so that no unwanted access is going to be happen. So this is how the best practice of preventing your application from an attack. Now, you can take a screenshot of this. These are the basically categories, purpose, and popular tools. which you can use for your cyber threat. One is the TIP. It understands that who is attacking, how, and which industries are targeted. Okay, it's a recorded future threat connect and anomaly. It's a kind of knowledge base. Predictive cyber defense, predictive like attacks and recommended preventive action. Okay, so these are the list of particular. You can go through each and every category and look into the details that what these tools are all about and how it is preventing the cybersecurity. So it will help you in your what I will say in your day-to-day activity, and if you are going depth into the cybersecurity courses, so this will definitely help you. Now the last thing is that I've explained about what the preventive action you will be able to take, how the cyber security team analyze the data and stop the attack, what is the predictive and what is the threat in intelligence is all about. Now the very important part is that best practice. You will be only able to stop the cyber attack in your particular organization when you will follow the best practice. Okay, so first of all is that as a cybersecurity team, you should be subscribed to this CERT.in. Okay, it's basically a national India's national cyber agency publisher. Okay, you register over here and you will be getting to know about all the early warning of the threat which are hitting into the Indian organization. Use the open feeds. There are free IOC feeds, list known bad IPs, domain, and file hashes. It is listed over here. You can go through that and you can put it into your log so that at least from this IP address, domain, and file hash, you will be able to prevent your organization. Whatever the information which are there, you can put it into your firewall so that it could automatically stop attacking to your particular platform or organization. Then monitor your exposure. It means that on a day-to-day regular basis, your student, your faculty members, what type of website they are looking into, whether they are directly exposed to the website or not. So there are a lot of website which nowadays has been blocked by the big IT companies because they are basically impacting their security. And one of the most important example is that this chat gpt, everyone nowadays is using chat gpt. The organization are using chat gpt and that is the free one they are using. So what they are doing is that what the resources doing is that they are uploading all the organization information to the chat gpt, and they are getting the structured information from them. But once you upload your college information, university information, or any organization information into that chat gpt, it will go into that internet. So once it goes into the internet, it is with the AI ML, and it can perform any kind of operation with those information, right? It can predict anything. So it's very dangerous. So big organization are purchasing the license one of the chat GPT, where the information will be there into their premises and it will not breach the particular organization. The fourth best practice is to, once you receive such kind of attack, then inform your colleagues, inform your information team that such kind of attacks are getting introduced. The same which I have did, I informed my information security team, and they are going to inform all my colleagues that if they receive this kind of attack, then they have to be very extra careful on this. Okay. So this is all from my end for today's session, and I hope you have understood about the cyber intelligence, the predictive action need to be taken, and what are the best practice you have to follow. Along with that, you can keep and make a note of this particular tool landscape, and you can go through this one when you will have the time with you. So thank you. Thanks a lot for thanks to everyone for joining this meeting and and giving your time for this particular session. I hope this is an information. Cybersecurity is more a kind of practice which every organization, university has to follow. Rather than it because see, I will tell you one thing why it is a practice, because most of the work, all this pattern will be defined by your cybersecurity team. Okay, as an individual, you should understand that what the action you have to perform, how careful you have to, so that at least you will prevent your organization, university, or server or your data from any kind of cyber attack. So thanks a lot for joining this meeting, and over to you, Shweta.
Yes, thank you, sir. As we come to the end of the today's session, I would like to express my heartfelt gratitude to our esteemed resource persons today, Ms. Nikita and Ms. Amit Chandra, sir, for sharing his valuable knowledge with us. I also extend my sincere thanks to all the faculty participants for your active participation and engagement throughout the session. Thank you, everyone. Have a good day, and small announcement, please fill the feedback form which I have shared in the chat box. Thank you.
Thank you. Bye.